The wall that we're looking at here is a cavity wall, very, very common in Ireland. 2 leaves of blockwork. We're at the outside here, this is the inside. And generally speaking, there's a 4-inch or 100mm cavity between those 2 layers of blocks. Now, first of all, you'll have to find out what's in that cavity. If it's a very old dwelling, it may not have anything in that cavity. It was quite normal not to insulate buildings at all, maybe in the 60s and 70s, or it may in fact have 50mm of insulation in it. Irrespective, find out what's in there. And one of the things we recommend, if it's suitable for your geographic location, is to fill that cavity. And again, you can find reference maps where this is perhaps not recommended if you're in, for example, a very exposed area near the coast. But let's assume that it's okay to do that. You can pump the cavity with this called blow-in bead. Essentially, you bore holes in the outside of your dwelling, and the blow-in bead is pumped into the cavity. All right, so now let's say you have 100mm of insulation. That really nowadays wouldn't be regarded as a very, very good level of insulation. So we've got to look at a couple of options to add more insulation, okay? Now, in this case, we've actually shown 2 things. We've shown internal dry lining, which we'll cover in a few moments, and we've shown external insulation, all right? So I'm going to talk about the external insulation approach first of all. You wouldn't generally do both. So if you're filling the cavity, you'll either do external or internal, not both. There would be a lot of work and a lot of costs involved in that. The insulation is adhesively fixed to the wall. So you basically mix up a special adhesive, you put it on the back of the board, and you press the board onto the wall. That's pretty simple. Now, in addition to that, we want to use some mechanical fixings, and I have some examples of those here. In this case, we're using plastic fixings because plastic obviously is less conductive than metal, so it's always going to be better to use a plastic fixing in terms of thermal bridging. You can see there's a nail inside in these fixings, but actually the tip of that nail is made from plastic, so there's a kind of a thermal isolation in that, which is very clever. There's some really wonderful products on the market now, and these are 2 different lengths, obviously, depending upon the thickness of insulation that you're applying to your project. Now, we're often seeing on projects nowadays that these fixings are actually recessed into the insulation. In other words, that they're sort of buried by about 20mm, and then you can get a little insulation dowel. It's a bit like a rice cake or a little button, if you like, of insulation, and that presses over that. So that would actually reduce that thermal bridge effect even more. Okay, so moving along then. So external insulation is prone in some cases, if it's not done correctly, to what we call stress cracks. And one of the stress cracks can happen here at the corner of windows and doors. So a very important technique in terms of external insulation is to have an L-shaped board. This board originally was this wide and that high, and you can see so this is one continuous piece here. We don't have a joint there. That's very important in terms of avoiding those stress cracks. Now, also important is to have reinforcing mesh here at the corner. This whole thing will be covered in reinforcing mesh at some point when it's being rendered, but we put an extra layer of reinforcing mesh at a 45-degree angle at the corner, again to give that a bit of strength. And the last thing I want to point out at this specific location here are these angle beads. So you can imagine, you know yourself, polystyrene is, quite delicate in nature, and we want a good, sharp, strong line here in order to, for it to be visually strong and also kind of mechanically strong. So what we do is we bond in these angle beads, which again comes with a mesh. And you can get the impression there, that's not even finished, obviously, how strong that is. The next and last thing I want to look at just in this particular view is the windowsill, okay? So in Ireland, it's quite common to have concrete windowsills, and if you've gone to the trouble of adding external insulation to your project, this obviously is going to be quite a thermal bridge, isn't it? Because this is all very well insulated, and now you have this thermal bridge here. So this is a rather clever cover, if you will. In the case that you want to leave the concrete windowsill in place, this is an insulated concrete sill, and it literally fits over the windowsill entirely, which eliminates the thermal bridge. We'll have a look at this windowsill from a different perspective in a moment, but it's a really clever invention, if you will, to try and get rid of that thermal bridge effect. And all of these systems now come as a system. You get the adhesive, you get the insulation, you get the fixings, you get the dowels, you get the mesh, and all of that. So it's kind of really bulletproof, and there are several of these systems now which are approved by the NSAI, so you can use those with confidence. So we'll just have a closer look now at the windowsill. So here's your traditional concrete windowsill, massive thermal bridge, and look what we've done here. We've completely wrapped it in insulation. This looks and feels and behaves like concrete, but in actual fact you can see here it's polystyrene insulation, the same here, and we've actually carried our external wall insulation underneath the windowsill as well. So we completely encapsulate that, if you like. We put a sock on it, which will reduce the heat loss from the building and reduce any risk of mold on the interior. We're still now in our cavity wall situation, and let's say you decided you don't want to externally insulate the dwelling, you want to internally insulate it, or we call that dry lining. So we've got an example of that here, which I'd like you to look at. This is very, very common in Ireland, as you can imagine. So we're seeing the original blockwork here in the background. We're obviously going to insulate that now. We've got an insulated plasterboard. It's a sandwich, if you like, between insulation and plasterboard. It says it in the name, I guess. We're mechanically fixing that. This is one way to do it. You can mechanically fix it directly through to the concrete. We'll show you an alternative approach as well, where you can fix that onto timber battens. But anyway, this is one approach to do it. And we wanted to make sure that we actually insulate the whole window reveal as well. It's not just enough to do the wall, we want to do the window reveal. So you can see that we're starting to do that here. We've left some of it exposed so you can see how it might be in the beginning. You can see here as well, it's very important that we make an airtight connection between the window and the masonry. Otherwise there'd be a lot of air leakage there, and you would feel that as drafts, and you would experience that as cold air infiltration, which would increase your heat losses. So we're not only insulating the reveal, but we're also making it airtight. So that's kind of nice to see. And obviously that continues around the top and down the sides as well. Now, if we just come over and have a look here, then we're obviously going to plaster that. You wouldn't, people are generally not going to be happy to leave that like that. So often we're mostly skimming this as well. So you can see a nice smooth skimmed finish there, and you've got your electric socket here and so forth. So when it's all finished, it just looks like a normal wall, but in actual fact behind this is a decent amount of insulation which will improve the comfort in the home.